Hello everybody and welcome to today's video. You might be wondering to yourself what the hell I'm wearing. Well, it doesn't matter because in today's video, much like this attire, it's going to be an experiment. What we're going to be doing today is we're going to be taking these two bottles of similar volume and we're going to put to the test a simple question. What drains water faster? The vortex when you spin the bottle and just shoots it out, or simply just turning it upside down? We're gonna find that out in today's video. If you already know, shut up. If you don't know, keep watching. This is gonna be fun. I'm gonna have a fun time explaining this from my perspective because I don't actually know the right answer. But if I am able to guess the right answer prior to looking it up, that just makes me hello and welcome to my super elaborate laboratory. It's not a bathroom, and this is not a bathtub. It's a laboratory, but super fancy. So this is how the experiment will run. I will turn one bottle upside down, and then for the next bottle I'm going to create a vortex. Alright, we're gonna get started in 3, 2, 1. As you can see, the bottle that I flipped upside down, it emptied a lot slower than the bottle that I did a vortex with. To really drive this experiment home, let's do it another time. So both bottles with the same exact volume of water, maybe not, no, probably exact, and then same temperature of water. Let's do this again in 3, 2, 1. Okay, I'll be honest, that one was a bit fast. Not sure which one came out on top, but I think our experiments reigned conclusive. As you can see, the vortex, I think it was, is faster actually than just pouring the water straight out, which was interesting. I immediately thought that that's what would happen. Without a doubt in my mind, I always thought that the vortex would be faster. Now, my theory behind it, and I'm pretty sure that this may be the cause, is because, is it water displacement? Is that what I'm thinking of? Either way, there's a thing where the water that's falling out, the one that just becomes turned over, gravity takes that water and it pours it out. But because the pressure in the bottle wants to try to stay consistent, it has to replace it with air. So in that case, because it needs to replace it with air, it takes longer, it takes more breaths essentially for the air to go up, instead of just being replaced instantly or like squeezing the bottle. Because if I crushed that bottle, definitely water would flow a lot faster, but because it has to replace air and that way it replaces air so slowly, I think that's why. It also creates a sort of vacuum. Like the bottle, the difference in pressure creates a sort of vacuum, and so the water needs to make way for the air to get through, so it has to take time. So essentially the water is sort of stopped at some points, or a little bit of water makes it through while a little bit of air makes it through, and that sort of transfer is a lot slower. The vortex, on the other hand, it makes water, essentially when it's spinning around inside, that water, it doesn't touch any of, it's only touching the bottle really, it's not touching any sort of air. So there's no real transfer of water first, then air, water first, then air. It's all simultaneous. So the water is being sucked out due to gravity, but that vortex allows a sort of circle of air, allows this hole of air to just allow the transfer to happen, or allows the it allows the equilibrium, I guess, to happen. So while water is being sucked out, the volume is being instantly replaced with air. So as air goes up, water goes out. But there's no pauses in between because it's not always just water first and then air, like how when you turn the other bottle over, it's water and air moving simultaneously. So the first bottle, water comes out, air needs to go through and replace it, right? So water comes out, air comes through, water goes out, air comes through. But with the vortex, what it is water goes out, but air can always just pass through no matter what. And I think that's what it is. The difference in pressure in the bottle creates a vacuum, and if the pressure can't be equaled out, then it'll do what it did with the bottle that was just flipped upside down. But if there can be an equilibrium instantly, then it'll do what it did with the vortex. And I think that's the explanation for it. I'm pretty sure I confused myself halfway through. I don't really know if that's the right thing about it. I'm pretty sure it is. But I don't know. Just this theory. A science and life fact theory. Thanks for fucking.